9.3 extra examples, last part, number 7 and 8. This is about Rock Station claiming they play an average of 50 minutes of music per hour, but it seems like they don't. So, because every time you turn on the radio, it seems like it's less. So here's 12 samples of how many minutes of music are played. Check the conditions. So a random sample of hours was selected. Normal, the sample size is too small for the central limit theorem, so you would have to graph the data. You could do a dot plot or a box plot, and the data would be roughly symmetric with no outliers. Independent, assuming there are more than 120 hours of music played, and then you would compute the statistics using your calculator, x bar and s sub x. The test statistic would be 47.9 minus 50 over 2.81 over root 12. Negative 2.59 is what you get for your test statistic with 11 degrees of freedom. So let's see what we can do using the table with that. So using the table, for 11 degrees of freedom, so we're right here, 11 degrees of freedom, we're going to look for negative 2.59. So this is the way this works. Here's the table. Notice for a t distribution, the area is to the right, not to the left. So for t of negative 2 so degrees of freedom 11, so you go to the line for 11 degrees of freedom, and then negative 2.59 is well, we don't see that. We want less than, it's because of the symmetry, we can use positive 2.59. It's going to give us the same area. So we look for 2.59 for 11 degrees of freedom. 2.59 is between these, see, it's between these two values. For 11 degrees of freedom, it's between these two values. So all we can say is it's between 0.01 and 0.02. If we just use the table, that's what you'd have to say. You can't get any more specific. 0.01 and 0.02. But it's good enough to tell us that, well, it's just good enough to tell us it's between 0.01 and 0.02. Our calculator would give you 0.0126. Okay, so that's all that question is asking. It's not saying to conclude anything. It's just computing those values. So let's practice using the table again. Let's try this. If you sample size is 75, you have to use the most conservative degrees of freedom, which would be 60, because there is no 75. So if you go here, once we get up here, there is no 75, so we're going to have to use the one lowest, which is 60. And then t is 2.33, they tell us. So you go over to 2.33, 2.33, and it's between these, so you could say it's between 0.02 and 0.01. If you look up above, it's between 0.02 and 0.01, and that's all you can say. Is there a question?
It was like
90?
90 though. So go for 60?
For 90, you would go for 80, because 80 is, yeah, but yeah, you would. Yeah, whatever's lower. Yeah, good question. So last one, we're just practicing the skill. So degrees of freedom at sample size 10, degrees of freedom 9. Now watch this. It's like not even, oh, and we want a test statistic of negative 0.51. So we'll look for 0.51. So degrees of freedom 9 is there, but there's not even, the smallest value here is 0.703. So we just know that it's bigger than 0.25, right? As you go to the left, these are getting bigger as you go to the left, but we can't conclude anything else except that it's greater than 0.25 by using this table. So you would have to say the area under the t curve, to the right of 0.51 is greater than 0.25. And since it's a two-sided test on this, because it's mu not 10, you would double it. So the p-value, all you could say is the p-value is at least 0.50. At least 50%. I mean, that's pretty big. So it doesn't really matter how much bigger. It's at least 50%. So that's how that works.